Alright, so you should have just finished the math antics video, and again, I understand that it's a little goofy, but, you know, there are some good things there. And really, I like, in general, how he explains prisms. Prisms are just a regular two-dimensional shape that we're used to that's stretched out, so now there's depth to it. And with a couple exceptions, we normally just name it based on that geometric shape. Now, there are a couple exceptions here. Number 1, for example, is one of those exceptions. Number 1, you should know, is a cube. And numbers 5 and 6 are the exact same shape. And while we see that that shape is a circle that's stretched out, it's not a prism, because technically a prism has to be a polygon. So numbers 5 and 6 together are both cylinders. So, again, I know that it's not technically called a prism, but if we remember that it's the same idea as a prism, we use the same basic idea to find its volume. So, 2, 3, and 4 are 3 different types of prisms, and again, we name them by their shape. We'll talk about that when we get there. So let's look at the cube. In order to find the volume of all these, we first need to find the area of the basic shape. So the cube, you should be able to see, has a basic shape that's right in there. It's the square up front, so we know that we're going to take its base times its height to get us the volume of the square. And I know it's a little weird depending on how you're looking at it, but I'm looking at this right here as that front shape. So when we do our 6 times 6, we get an area of that base of 36 square centimeters. Then we're going to take that same volume, or that same area rather, 36, and multiply it by how deep it goes. So we're going to take 36 times 6 to get our total volume. And when we do 36 times 6, we get a volume of 216. Now we need a label. So the easiest way to remember it is a 3D shape gets the third exponent. Just like with our original trick when it comes to when we're dealing with squares finding the area, we can just square it. It's the same deal here. When we're dealing with a cube, we can cube it. So we can have the idea of 6 to the third power, or 6 cubed, and that equals 216 centimeters cubed. So the answer for number 1 is 216 cubic centimeters, or again we write it as centimeters cubed. Make sure you're copying this down, and if I were you, I would write down how we're coming up with each of these. In fact, maybe up top here, it would be worth your while to do something where we talk about the volume is the area of the base, and remember that's what that capital B stands for, times, keeps wanting to do something different, there we go, times the depth, or how deep it goes. I like how Mr. Dansbury sometimes describes depth. He describes it as the distance, D for distance, between the two bases. Alright, let's take a look at number 2 now. Number 2, our basic shape that we started with is a triangle. You can see we have a triangle that's stretched out to another triangle. So we need to see if we can determine the basic shape of that triangle. And you can see that it's actually an equilateral triangle. So it has a height of 3, and it has a base of 3. I don't really like the way this one is drawn because it's really hard to tell what the base, which one's the base and height. It almost looks like those are the slant height. But if it wasn't the actual base and height, there's no way we could actually do this problem. So we can safely assume that that's the base and the height. So remember, to find a triangle, we're going to take the base times the height and divide it by 2. So then we have 3 times 3 is 9 divided by 2. 9 divided by 2 is 4.5. So that's our triangle. But now we need to multiply how deep it goes by the area of the base. Notice it says in the directions that we can round to the nearest hundredths, so we don't have to round it yet. So we're going to do 4.5 times 6, and it comes out to 27 millimeters cubed, or again we say cubic millimeters. If you're starting to feel a little comfortable, try to work ahead on number 3 and then check your work when I give the answer. Number 3 is a rectangular prism because we're taking a couple rectangles on the edge and stretching it out. Or you can see it like we took this one big rectangle and stretched it back. For me, it's easier to see this big rectangle up front and stretching it back, so that's how I'm going to assume it. So I'm going to find the area of the big rectangle up top. So to do that, I'm going to take its base, which is 14 feet, times its height, which is 8 feet, and the area of that front triangle is 14 times 8, or 112 square feet. Now I need to take that 112 and multiply it by how far back it goes. Now there are probably some of you that are understanding that you can just multiply all 3 together, 14 times 8 times 4, and if you understand that, that's fine. Otherwise, just take it step by step. So again, we're going to take our area and multiply it by 4, and when we do 112 divided by 4, multiplied by 4, we get 448. Let me write that a little smaller. 448. And again, because I see feet, make sure our label is cubic feet. So 448 cubic feet. Next, we have the trapezoid, which obviously is everyone's favorite. So let's see if we can remember the trapezoid. Well, I see that trapezoid is stretched out, so to find the trapezoid, I'm going to write it above number 4, the formula, so you can work ahead if you'd like. So we have our base 1 plus base 2 times the height, all divided by 2. Or on your formula sheet is 1/2 b1 plus b2 times h. Alright, so our two bases are the lines that are parallel, so that's our 2 millimeters and our 10 millimeters. So 2 plus 10 is 12 times our height. Remember, height can never be slanted, and it's telling us that our height is 3. We're going to divide that by 2. Well, 12 times 3 is 36, divided by 2 is 18. So the area of this trapezoid is 18 millimeters. Now I'm going to multiply that by how far I've stretched it back this way, which is another 3 millimeters. So I'm going to multiply my 18 times 3 to get the entire thing, and 18 times 3 is 54 cubic millimeters. Finally, we have our two cylinders. So we have to find the area of the circles and then multiply it by how far we stretch those circles. Now, number 5 is a little tricky because we know our area formula, area equals, and it's Fuzzy Wuzzy Was a Bear, area equals pi r squared. And just for all of you who are waiting, no they're not, they're round. Anyway, we need the radius, but number 5 doesn't give us the radius. 7 is actually the diameter. So the radius is only going to be halfway. So it's only half of 7. So here, the radius equals 3.5, which is going to be real fun to work with. I really appreciate them doing that. So we're going to take the pi times 3.5 squared. Fortunately, we have calculators, so we can type into a calculator 3.5 squared, which is 12.25. So I'm just going to erase, or tell you what, I'll cross it out and write 12.25 so you can see where I got it from. And now I'm going to multiply that by pi. So I'm going to multiply it by 3.14. Or again, you can use your pi button. And remember, it says to round to the nearest hundredth. That's the second place. So you should, once you multiply them together, get 38.47 once you round. 38.47. So, just for space's sake, I'm going to erase this. 38.47. Now, the calculator I'm using doesn't actually have a pi button, so if you multiply it by pi and then multiply by 10, you're going to get a slightly different answer that's more specific, and yours is actually a better answer than what I'm going to give you, but if you have this, you're still okay. Finally, I'm going to take the area of the circle, which is right here, and multiply it by how far I stretched it, which is 10. Which means all I'm going to do is move that over 1. So my final answer is going to be 38. Now I have that 4, and now it's 0.7. So 384.7 cubic yards. Last one I'm going to show you on here is number 6. And unfortunately, this one is a little bit nicer to us. Same deal, I still don't have a pi button, so I'm going to estimate pi as 3.14. But here, the area of number 6 of that circle, it already gives us the radius. So we have pi times 6 squared, or 36 pi. 36 pi, which I'll write down below here. We have 36 times 3.14, which is 113.04. Now we have to multiply that by how far we stretched it, so we're going to multiply by 8, which gives us a grand total of 904.32, and it's cubic yards. So, cubic yards. That's my creative way to deal with the lack of space. There are 3 more problems on here, 7, 8, 9. In the couple minutes that remain at the station, please complete those and check it with the rest of the group. Good luck!